Hey, hi everyone. Welcome back to my channel LinkedList IT Service. In this session, we'll be understanding about a linked list, what exactly the linked list, and we'll try to discuss the few points about the linked list. Okay, like what data structure it follow, what is the behavior of the linked list, and how it can be implementation. And then what are the different methods can be implemented by using linked list. Okay. Then we'll take an example to understand how to work with a linked list. Okay. Then last thing is uh, in another video, we'll try to make a case study how to work on the linked list with the real-time scenarios. Fine. Okay. So let's begin now. Let's understand about linked list. So the first thing, guys, as I said here, we had so many implementation class of the linked list, right? Sorry, a list interface. Like we have ArrayList, we have linked list, we have stack, we have the vector. Among all the things, we already had discussed about ArrayList and already have uploaded the video. Please go and watch that video there. Now, the second thing is I'm making on the linked list, which is also important here, especially when you're working okay with the data structure there. Fine. Linked list. The underlying data structure linked list, okay, will follow as doubly linked data structure. See, as I said for you guys now, in case of collections, each and every classes internally follows some data structure. So when I just talk about the linked list follows some doubly linked data structures. How it can be present, guys? So let's understand how it can be present now. If you just look at here, it contains a group of nodes, and each node contains three things. One is previous address as well as next address. In between, we have the data. Okay, we can create any number of nodes and we can store the data there. Okay. Now, so for understanding purpose, let's take a simple, understanding here, how we can work with that here. So let's open here. Let's just opening here. Just wait. Where is our dashboard? Let's open the dashboard here. Whiteboard is available. Okay, if it is not available, let's open the, okay, paint here. Let's open the paint. Okay, great. Now look at it, guys, how it can be replaced. Now let's take here, this is a node, as I said. It contains the three things. Let's assume that I'm storing some value here. I'm storing some value here. Let's say 10 here. Okay, now. So we had this node. Let's create another node here. It contains the three things. Previous address, next address, and the data. Let's take 20 here. Okay, let's create another one. We'll have previous address and next address. Then we have the data here. Let's take a 30 here. Okay. Okay, cool. So now if you just look at, we have three nodes, right? So each and every node having some address. Let's say, for example, I'm just giving guys some sort of memory here, 1004, 4 bytes of memory for each one, 1008 and 1012. Okay, right? These are my memories. Now, how it exactly is working? As I said here, it contains three nodes, the previous as well as next node here. Now, if you just look at here, it was connected to the next node, and the next node address is what one? We have 1008. Yes or not? And it also contain the previous one here. So what is the previous address we have here now? 1004. Okay. Similarly here, it contain the next address. What is the next address here now? 1012. And what is the previous address for this one, guys? Now? We had 1008. Okay. And here we don't have any address. I'm just writing as a null here. Okay. Okay. So now, as I said here, so maybe we have the head one here. Okay, so here it is having some address. We are not bothering here. Okay, na? Let it be whatever it can be. Probably it is going to connect here. Okay, na? And this is going to connect for this one here. Okay. So I'm just writing the head part as initially we'll take null and then we'll take the reference of that. Yeah. So probably if you just look at the representation of doubly linked lists, this is how it can be represented. Now, when we add the elements, that means we are just adding the new node, internally is creating that one, and trying to store here and connect based on that previous address here. Okay, na? Now, basically, if I just look at carefully, what exactly the advantage if I use the linked list here? Okay, na? So if I just look at here, duplicate objects are allowed. Insertion order is preserved. We can store the null value. And the most important thing is, guys, if you just look at here, heterogeneous objects are allowed. So that means we can store the different type of objects here. Okay, na? Different types of objects we can store. But the most important, the advantage of using the linked, you need to understand here. If you want to, if you want to insert or delete, remember this one, guys. Okay, if we want to insert or delete the element, okay, in between the okay, in between, this is a requirement here. Suppose I want to insert the element in between, okay, 20 and 30. I want to remove the element in between the 20 and 30, right? Or I want to remove the element as 20, right? Because it is a between 10 and 30 here. So in this scenario, it is always good practice to use, what a linked list here. Now the question is, why? Why? Because, guys, it is not shifting the elements whenever we insert or remove as the ArrayList does, right? So in case of linked list, the advantage is whenever we have the frequent operations like inserting or removing in between, always prefer linked list because it will just interchange the link rather than shifting the elements there. So what exactly the meaning of this one? Then let's say, for example, in between 20 and 30, I want to insert the new node. Just imagine. I just want to insert a new node. Just imagine. Okay, whose address is something, yeah. We are not bothering address. Okay, you just take an example to understand here. So here, if you just look at, we had the new node. That is, let's say, assume that we want to insert 25. Okay, now this 25 I want to insert in between 20 and 30. So what is the behavior in case of WFS? So what it does, it will not shift the elements. Rather than shifting the elements, people, it will interchange the connections. So like, for example, now it is not connecting this one. It will connect here, this one. So what is the address here now? 1000. So here we have 1014 address. Okay, 1014 address. And this previous address, it will be stored here. Okay, now, so whatever the previous address here, those previous address will be stored here. So we get 1012. So now it won't connect here, it will connect here. I hope you're understanding this now. Got the clarity now? Yes or not? So probably here the advantage is so rather than shifting the elements, it will just interchange the links here. It will just interchange the link here. So that's the advantage if I use what ma linked list here. Okay. Next thing is the most important point. When you're working with the linked list, guys, we can implement the stack, we can implement the queue, we can implement the TQ. So what exactly it means? Let's understand with the documentation here. So if you see the documentation, that is the API document I have open, so we can save our time here. So if you just look at the class linked list, this linked list class has been extended the abstract sequential list and implements, can you see, guys, list, DQ, clonable, and serializer. So these are the interfaces which has been provided implementation by linked list. Now, because of this here, we can see that it will use, it will it will use the following methods. What are the following methods, guys? Now you can see add first. Okay, add first, add last. This is because of DQ here. Okay, na? So if I just go for understanding purpose, let's understand here. For DQ, let's see what are the methods. Can you see, guys? Now we have add first. Okay, remove first, get first, offer first, pull first, peek first, add last, remove last, get last. Okay, all these methods, okay, has been defined here. You can see all these methods: add first, add last, okay, get last, offer, peek, poll, yes or not. And even though it is implementing the stack here, can you see that there's a reason I've written stack, pop, push, okay. So all these methods are belonging to what? DQ. So all this has been overwritten, has been written the implementation for this one. All these methods you can see, push, pop, everything is available. Okay, na? So that's the reason I've written the point, guys. If you just look at, able to implement the stack queue DQ. So that means whatever the methods which can perform the operations, all those operations are the methods we can use in the linked list there. So this is very important here. Okay. The last point is also important here. If you just look at according to the specification, by default, all the methods are non-synchronized. Can you see, guys, now? Non-synchronized. So that means we can access multiple threads. Multiple threads can be accessed at times. Okay, it is not synchronized by default. It is a non-synchronized here. Okay, now this is very important. Fine. So these are the few points you have to remember. Okay, let me come back here. Let me make you to understand. The first thing is the underlying data structure is a double data structure, and we understood how it can be looked and what is the advantage when you compare with a list, right? Next, duplicate objects are allowed because it's a list category. Insertion order is also preserved, which is very important. Null insertion is possible. We can store the null value also. Next one is what one? As I said here, heterogeneous objects are allowed, and we can also use linked list in order to implement the stack queue and DQ. So this is a very important points you have to remember here, right? Okay, now let's do one thing. Let's start doing the coding and let's understand how we can use the linked list here. So let's create a class, guys, now. Linked list demo. Let's create here main method. Okay, let's do one thing. Let's perform some operations for adding as well as removing. We can also do updation also. Okay, we can also implement other things, depends on the requirement. So first thing is, let's create the linked list. How we can create the linked list? Let's create the linked list, and what type of elements you want to store, you can decide it here. Depends on your requirement, you can use. First, I want to store the integer. Okay? The list we have new linked list. Okay? So now if you see that we just created a linked list. So when you create a linked list, it will create the empty linked list. Okay, let's see that. Now we got the empty list now. So in this empty list, we want to store list now. Okay. So list dot add. Okay. So now this 10 element has been added in here inside the node. So that means, can I say the first node has been created, guys? No? Yes or no? The first node, it has been created or not? Yes, the first node it has been created here. So that is what 10 is created here. So it contains the previous and the next address, right? Okay, so now we can add here, let's say 15. So now 15 also connected here. 15 is added, so it was connected here like this. Okay, right? So next, let's add it here 20. Let's add it here 25. So let me add the few elements only here. So we have another node, guys. This is how the node is connected here. So 20 next is connected here. And then we have another node that is 25. So it is connected here. Okay, so 10, 15, 20. So now if you just look at, can I consider the insertion order is preserved? Yes or no? Now look at guys now. So we got 10, 15, 20, 25. So the insertion order is preserved. Insertion order is preserved. Now, as I said, we had the different methods. By using those methods, we can able to perform the different operation. As I said, we can able to implement the stack, right? We can do it this one, right? Now, how we can do guys now? We can, let's say, for example, I just want to add the 5 element at first. Is it possible, guys? List dot add first. Yes. So what happens now, guys, now at this point here, we can say that add first, it is created one node here, that is 5, and it has been added here. So now head is pointing to where now? The head is pointing here. Okay? So head is pointing 5, right? So what is the output you are expecting now? If I just print it, guys, now. So we get here 5, 10, 15, 20, and 25. Yes or no? Let's see. So can you see, guys, now? It is added 5 here, 10, 15, 20, 25, right? Okay. So, sir, can I possible to be insert at last also? Yes, we can store. Okay, now let's see that now. List dot add last. So last I'm adding 30. So what happens now, people, at this point now? It has been created the another node. Yes, it has created the another node. Right? It is created the another node. And in this node, it has been added what? The another element. Yes or not? So that 30 is added here. Okay. And this will be connecting here. Okay. This will be connecting here. So this is null. Okay. So now look it carefully now. Let's see, is it working or not? Yes, we got 5, 10, 15, 20, 25, and 30. So perfectly is working here. Okay. So now not only this, as I said, you can also remove first. You can remove the first. You can remove the last. Okay, now. So it depends on the requirement. Okay? So remove first, remove last. Now, when I just make it here, what is the expectation, guys? So now this element has been removed. Now head is pointing here. And this element has been removed and this became null. Yes or no? So what is the expectation now? The expectation is what? 10, 15, 20, and 25. So we get 10, 15, 20, and 25. So perfectly is working, guys. Okay, so like this, you can do number of operations. So let's say, for example, you can do the set. Means you can also update it. That means you can replace the element at the specified position in the list. Okay. How? For example, based on index here. Let's say, for example, at index 10, I just want to make 11. Let's say 0 index. I want to insert the new element as 11. So what is our expectation, guys, now? So in place of 10, it's become what? 11. Let's see, is it working or not? Now, previously we have 10. Now it's become what? 11. So we can update also. We can update based on the indexes here. Okay, right? So like this, you can able to perform the various operations. We can able to access also. Let's say, for example, we have done insert, we have done update, we have done remove. Now let's see how we can access individually. So for accessing individually, as I said, we can use iterator. We already have discussed about iterator in the separate video. Please go and watch there if you want. Okay. So we can have the iterator. I can take the iterator here, import the package. Now, once we get the iterator, let's check out here whether this element is there. If yes, I just want to print on the console here by using
next method. So we can able to access here individually. Can we access individually, guys? Yes. Not only this, let's say we have, sorry, let's start. Let's see. We have, what is this one? Descending iterator. So that means we can perform reverse direction also, descending order. Okay. So we have, just wait. Let's start descending order. Okay. So we get in the descending order. Next, and then we can get here. Next. So we get in the reverse order. We get in the reverse order. Let's see more. So I'll just make it here, line here, so that you can understand. Okay. Now, can you see, guys? Now we got in the reverse order here, 25, 20, 15, as well as 20. So with the help of what? Descending iterators. So that means we can move in, okay, forward direction here. It is moving from where? Back direction here. Okay. So like this, you can able to perform the different operations, depends on the requirement there. Okay. So I hope it's clear for you how to start working with the what a linked list here. Fine. Now, if somebody asks you the interview question, so what is the interview question here? Now, this is very important here. If somebody asks you, okay, if somebody asks you, what exactly the differences you are finding between ArrayList and linked list? ArrayList and linked list. If somebody asks you, what differences you are finding? Let's understand. So this is one of the interview question. If somebody asks you, you need to be answer. Okay. Now, basically, if I just look at here, guys, when I just talk about the ArrayList, ArrayList is an implementation class of list interface. We can store duplicates, right? Linked list also is an implementation class of list interface where we can store duplicate objects. But what differences it is? The differences is, if you just look at, first difference is in terms of data structure. The data structure will follow by the ArrayList is resizable array data structure, whereas linked list did follow the doubly linked data structure. Okay. Now, second difference is, first difference is in terms of data structure. Okay, the first thing is in terms of data structure. Okay. So which data structure it follow, guys? Now it follow resizable array data structure, and it follow the doubly linked data structure. Okay. Now, second differences you are finding here is, if you perform insertion and deletion of the element, if you perform insertion and deletion, okay, element in between, okay, it is very slow. It is very slow compared with the linked list. In case of linked list, insertion and deletion in between is very fast because it will just interchange the links. It will just interchange the links here rather than shift the elements. But in case of a release, we have to shift the elements. We have to shift the elements here. I hope you're understanding, guys. So for example, if you take a list, let's say for example, we have 1, 2, 3, 4, and 5. Just imagine. We have the 5 elements, right? Now suppose I want to remove the third element. If I want to remove the third elements, we have to shift the remaining 4 here. Yes or no? Right? Suppose I want to insert the new element in between 3 and 4. Let's say I want to add here some 11 here. Yes. So we have to shift these elements. First, we have to shift 5 element. Then we have to shift to 4. Then we have to insert new element. So generally the shifting process is become very slow. Okay. Especially when you're working in between here by using arrays. So it is not good practice to use ArrayList whenever the frequent operation is insertion, deletion in between. Rather than using ArrayList, go for what? Linked list. In case of linked list, what will happen, as I said for you guys know, it will just interchange the links. It will just interchange the links. So that's the reason. That's the reason. Okay. Always prefer the linked list if the frequent operation is in between. In between. Okay, guys. I hope it's clear. So this is the basic difference between the ArrayList and linked list. I hope everyone is clear. Let me repeat once again. If you use ArrayList, internally follow resizable data structure, whereas linked list follow doubly linked data structure. ArrayList can be preferable if you want to search, or if you want to get, okay, if you want to get the elements, then always go for what? ArrayList. Okay. Linked list can be preferable if you want to perform insertion or deletion in between. Then always good practice to go for what? Linked list here, right? So this is the basic differences you can find between ArrayList and linked list. I hope everyone got the clarity, guys. Fine. Okay. So in the next video, we'll be understanding how to work with the case study on the linked list. I'll take in some case study here and I'll be making to understand here. Fine. So that's it for today. Thank you so much. We'll catch up in the next video here. Fine. Till there, take care and bye.